Okay, so question 4 was actually a wave question, and it was actually looking a little bit at double slit and also a little bit on standing waves. Now, a lot of people get a little bit confused with this question because it starts talking about a voltage, but basically the voltage is just detecting the light sensor. Okay, so basically when it gets a maximum intensity, it's getting a maximum voltage. Okay, when it has a minimum intensity, it's going to have a minimum output voltage. So it's really careful with this question. Okay, I'm going to come back to this page in a second, but I'm going to go over to the questions on this side. So it says, explain with the reference to light passing through the slits why a series of voltage peak occurs. So basically, as light goes through the slits, okay, because it's going through a double slit, it interferes or superimposes, causing a series of maxima of constructive interference and minima of destructive interference. Okay, so essentially, what I've got is the light passing through a double slit, we're going to get an interference happening across there. Okay, so light is superimposing. Okay, I've then just sort of made it really clear why the voltage peaks. So the voltage at a peak when we're at maxima. Okay, I could even say here when we're at constructive interference. Okay. Section 2, so part B, the slits are separated by 1.5 millimeters. Now, this equation we're going to be using as Young's double slit equation, so I'm going to use S is equal to lambda D divided by D. Okay, so remember, slit separation is our little d, and I've just put it there times 10 to the minus 3, so don't forget that's in millimeters. The laser light has a wavelength of 6.3 times 10 to the minus 7 meters, and the slits are 5 meters from the train track, so that's our large D. Calculate separation between the adjacent positions of the train where the maximum voltage is. So that's our fringe, okay, which is our S value. So simply this, S is equal to lambda D divided by little d. And I just had to plug in the values, just remembering to put 1.5 times 10 to the minus 3 in there, which gave me 2.1 times 10 to the minus 3 meters. The next one was then saying estimate the speed of the train. Okay, and it's worth 2 marks. Now, speed is equal to distance divided by time. Okay, so what I can use here is I start thinking, well, what distances do I know? Well, I know from the answer above the distances between the minima. Okay, so I know the distances between the minima. So thinking about the interference pattern we're getting, I know this distance here. All right, if I look back on at my page on the front, okay, I've actually got that output voltage, so each of those are my I keep saying minima, so I've meant maxima. I've got my maxima up here, okay, and I've got my time between them down there. So the time between these two is 25. It's in milliseconds, so I have to times it by 10 to the minus 3. So what I then do is I use my answer from above, my distance between my maxima, okay, and then I divide it between the time between the maxima, and that gave me 0.084 meters per second. Okay, so that was a little bit of a tricky one. We had to use the graph there and had to kind of use that idea, although it was a really simple equation. It's a little bit harder to figure that one out. The last one was then saying if we had a train, but this time it was at a barrier, why would I still get the same amount, the same pattern forming as we do when it's going past that double slit? Well, essentially here we've got to think that the wave is sending out is in terms of like being reflected back off the barrier. Okay, so the wave is going out and it's being reflected back against that barrier. Okay, we should know that when we have waves going against a reflection, we form a standing wave here. So you need to have some sort of mention of that in the top. So I said here, as the wave reflects back off the barrier, it's traveling in the opposing direction to the original wave. This forms a standing wave. Okay, your examiners are never going to see these diagrams, so you need to make sure you explain this in words rather than just drawing it at the top. So then from here I would say that maxima is going to form at the antinodes. Okay, remember these being our antinodes, and the minima would form at the nodes. Okay, so I've linked it back to my standing wave terminology. And that was question 4.